The first kind of chemical reaction that I'm going to expect you to be able to predict the products from is the basic form called formation reactions, also known as synthesis reaction, also known as combination reactions. Our example to start with is zinc and oxygen, a metal with oxygen gas. Now zinc is a transition element, but zinc as an ion can only have one charge. Therefore, when these two compounds or elements come together and they collide and they react, zinc will lose electrons and oxygen will gain them, and you're going to end up with zinc having a 2+ charge and oxygen having a 2- charge. They are balanced, therefore there's no need to crisscross the subscripts. You're going to get ZNO as a solid. That compound is balanced internally, but the reaction is not balanced. As a skeleton equation, you've got 2 O's on the left. You need to add a 2 in front of the zinc on the right, and you need to add a 2 in front of the zinc element on the left. And that gives you 2 zincs and 2 O's left and right. So you got a binary ionic compound being produced, a single compound on the right-hand side, definition of formation, and the products were predictable because zinc as a metal only has one charge, and therefore you can put that together with oxygen and predict what the compound formula will look like. The second example here is cobalt with oxygen. Now cobalt is also a transition element, but the cobalt atom, when it comes into a compound with oxygen, can actually form 2 different kinds of ions. It could have been a cobalt 2 or it could have been a cobalt 3. So for transition elements that are multivalent, you will have to be told in the question with a hint what the reaction would actually make if you went to the lab. We get cobaltic oxide in this case. So cobaltic would be CO with a 3+, and the oxide would be a 2-. Therefore, the final chemical formula, when you balance your charges using the crisscross method, we get cobalt 2OCO2O3 as a solid. Now, the reaction itself, the compound formula is balanced, but the reaction isn't. So looking on the right-hand side, you've got 3 O's, left you have 2. You put a 2 in front of the product, that will give you 6 oxygens, and a 3 in front of the oxygen on the left will give you 6, and then a 4 in front of the cobalt to balance that last element. So metals that have only one charge, the compound formula will be predictable, but metals that have more than one charge, the compound formula would not be predictable, and you would be expected to write down what you're given based on the clue in the question, either by name or by giving you the compound itself. Now when you put nonmetals with oxygen, like nitrogen and oxygen, you can get more than one charge. Well, actually, you can get more than one product, better said. So nitrogen gas reacting with oxygen gas will produce a product based on the temperature and pressure at which those gas exist. So you would not be able to predict that based on the information you've been given right now. I'm going to give you the clue. What you're going to get here is dinitrogen trioxide gas. And with that clue, you can complete the reaction and you can balance it. So dinitrogen trioxide is a molecular compound. The prefix is dinitrogen N2 trioxide O3, which states a gas. Now your reaction is not balanced, but you can balance it by putting some coefficients in front of the appropriate reactants and products. You need to have the O's even, so a 2 on the right will give you 6 oxygens, a 3 on the left will give you 6 oxygens, and then a 2 in front of the nitrogen will balance the 4 N's left and right. So again, you had to be given the product when a nonmetal reacted with oxygen because conditions of temperature and pressure can change those outcomes. Last two examples I want to do here are when you have a metal and a nonmetal that's not oxygen. For example, if you have aluminum with sulfur. Aluminum, we all know, representative element Al. Sulfur in its state of just an S, not with the S8 this time. Aluminum and sulfur will react to give you a compound. Aluminum is a 3+, sulfur as a sulfides a 2-. So you would get Al2S3. It's ionic, so it's a solid. To balance the equation, all you need to do is add a 3 in front of the sulfur and a 2 in front of the aluminum, and the skeleton is balanced. That product was predictable because aluminum only has one charge in a compound. Now if you take something like chromium as a metal, which is a solid, and react it with iodine, which is a diatomic, it's also a solid. The product you're going to get is going to be binary, but is it going to be chromium 2 or chromium 3? And that's where you can't guess. You'd have to be given that information. So I'm going to tell you that this particular reaction is going to be chromium 3 iodide. Then you can finish the reaction. So chromium 3 Cr would be a 3+, iodide's a 1-. When you crisscross those, you get Cri3 as a solid. And then to balance the overall equation, you have to look at your nonmetals. You have 2 and a 3 necessary to get those to be equal to a 6, and you have to add a 2 in front of your chromium to balance it. So depending on if the metal is multivalent or not, the products will be predictable. If it's multivalent, you can't guess, you've got to be told. If it's not a multivalent, you should be expected to know exactly what you're going to create. Now if you put some molecular compounds with water, the example I've given you here on this page is N2O3, dinitrogen trioxide, and that comes together with water, you're going to get HNO2, aqueous. This is a reaction that produces an acid. And that acid, NO2, is a nitrite, so this should be familiar as nitrous acid. And to predict that, I wouldn't expect you to be able to do, but I would expect you to be able to balance the equation if given the skeleton. So you've got 2 N's on the left, you need 2 on the right. By putting a 2 in front of the acid compound, you actually balance the entire reaction. 2 H's left and right, 2 N's left and right, 4 O's on the right, and 3 and 1 makes 4 O's on the left. So formation reactions, you're going to have to be able to expect to be able to predict the products for those. And if it's a multivalent metal, you're going to have to be given more clues. If it's a representative element or a non-multivalent metal, then you can predict the products, and you should do so. Don't forget, skeleton equations should always be balanced.